Right.
We are on 5.3 part 2, and we're working with quadratic equations. So we have solve quadratics by graphing and solve quadratics by factoring. Now we're getting into some word problems. So here's a little bit of physics for you. Any object thrown or launched in the air, such as a baseball, basketball, soccer ball, is a projectile. The general function that approximates the height h in feet of a projectile on Earth after t seconds is given below. So this is your quadratic function. See the ax squared plus bx plus c. T stands for time, and we're talking in seconds, and h is the height of the object. So if you can imagine kicking a ball in the air, gravity pulls it back down, right? Whether you just try to kick it straight up or you kick it out, it's going to have that arc on it. And so that gives you that negative 16, that gives you that downward parabola. Now, when I draw this parabola, a lot of you are picturing a ball arcing the air and coming back down, but that's not what we're talking about. We're actually talking about time and seconds and height. And so in 0 seconds, the ball's on the ground if I'm kicking a soccer ball from the ground. Then I kick the ball, and as time passes, the ball goes up, it reaches its peak, and what's it start doing? It comes back down. So it's not that we're looking at the soccer ball. I could throw the ball straight up in the air. Time's passing, it's going up, and then it's coming straight back down. So time is passing, here's your peak height, and then it starts coming back down. And if we ask, like, when does the ball hit the ground, that's a height of 0, and we're trying to see how long it took for the ball to hit the ground. So that's visually what you're doing. This negative 16 is a constant. It's Earth's gravity, but we're measuring in feet per second squared. This is your initial vertical velocity. Because we're kicking the ball, there's an initial velocity when it comes off the foot. If I just drop something, you don't have initial vertical velocity. And then this is the initial height. So if you're at the ground level, the initial height is 0. If I'm dropping something from a roof, I have no vertical velocity, but I would have a height of 100 feet. Okay? If I'm kicking something off of a hill, then I might have initial height. Now, this model doesn't account for anything else. It's like being in a vacuum, okay, where there's no air, there's no wind, there's nothing in the way. We're not worried about how much air the ball has in it or doesn't have in it. So no air resistance, no wind, or any other real world factors. So this is the most basic one. So you have a soccer ball being kicked from the ground level with initial vertical velocity of 32 feet per second. And that should be, yeah, right there. After how many seconds will hit the ground? Okay, so if I'm using this formula, we are looking for t. T is time in seconds. And then h of t, they've already defined as height in feet. Now, in order to do my function, they said the initial vertical velocity of 32, that's going to be v sub o. And it says it's being kicked from ground level. So what's the initial height? H sub 0 is 0. So H sub 0 is different than H. H sub 0 is the initial, V sub 0 is the initial. All right, so here we go. We want to have the height with that gravity pull times t squared plus initial vertical velocity of 32 feet per second times time and initial height of 0. Now, if they're asking when the ball is going to hit the ground, what's the height I'm looking for? I'm looking for a height of 0. So I am trying to find the time when the y value is 0. All right, I missed my 2. So I am going to solve this by factoring. Now, what's nice about this is that's not there. So don't forget the first rule of factoring. Can I take out a GCF? Yeah, what's the GCF here? Yeah, always try the smaller number. Negative 16 divides into both, and you said negative 16t. So that's going to make it a positive t, and then a negative 2 left over. Okay, we're going to use that zero product property. Negative 16 will always be negative 16, but t could be 0, or t could be what? Positive 2. All right, so what do these answers mean? The 0, that's 0 seconds. Have you kicked the ball? In 0 seconds, the ball is 0 feet high. That's not what we're looking for. This is the answer we want. In 2 seconds, the the ball will come back to the ground. So in 2 seconds, the ball will hit the ground. And I say hit the ground, we're not talking about when the ball stops bouncing. So it's that first initial hit the ground. All right, so that is what you're doing. And this one we were able to factor. Now, this one is talking about a football being kicked from ground level, but it has a higher vertical velocity, that initial velocity, and how long is the ball in the air? When they ask how long the ball is in the air, when's the ball not going to be in the air? When it hits the ground. So the idea is the same. We are going to start with this as our vertical velocity. Again, it's ground level, so the initial height is 0. And we want to find the height. So h of t equals my formula, this time 48t, and then initial height of 0. All right, so now that I have that, I want to know when the ball is in the air. So we want h of t to be 0. So that y value is 0. Again, this factors nicely because that plus 0 is gone. GCF here is, again, it happens to be negative 16t, so they made it nice to work. And we get t minus, should be 3. Anybody agree? Okay, so negative 16 will always be there, but t could be 0 or t could be 3. So this is the time of 0 seconds. Well, we haven't kicked the ball yet. And then the ball is going to be in the air for 3 seconds. So in 3 seconds, the ball will hit the ground. So it is understanding what our variables are and what to use. I don't expect you to memorize this formula, but I think once you see it a couple times, it's easy to work with. Okay, good with that idea. If, again, you were dropping something off the roof, then you would have an initial height, but no vertical velocity. That comes from that force, that initial force. Okay, we did a quick recap on perfect squares and difference of squares. So I'm going to remind you, we're going to be doing some factoring here. I'm giving you something that might look like this. It only has 2 terms. And when it only has 2 terms, I'm looking to see if it is a difference of squares, but it's got to be a minus sign. And then if you remember, you get that 1 plus and 1 minus. So a times a is a squared. And then the outside is going to be a negative ab. The inside is going to be a positive ab. And last is negative b squared. And so we see that cancels and leaves us that a squared minus b squared. Now, the other one you have are called perfect square trinomials. If your first and last terms are squared and the middle works out, we might be a perfect square, and it's something times itself. So remember, you can't distribute a power over addition and subtraction. You'd have to write this twice. So we're going to reverse it. We're going to FOIL. First thing we need to do to find the roots using special factors. If you're asked to solve by factoring, I'm looking for the factoring and the answers. Okay, so you get points for factoring, points for answers. We're going to use that zero product property. We always want to set our quadratic equal to 0. And to use the zero product property, we need a product. So zero product property from yesterday said that a times b equals 0, then a equals 0 or b equals 0. So we need to set it equal to 0. And when we're solving a quadratic, remember, to solve, we are trying to find x when what? When y is 0. So that's why we're setting it equal to 0. And remember, you could be using the term roots. So when I say solve, you could be asked to find the zeros or the roots. Both of those ideas are telling you to solve a quadratic. So I just want to keep throwing that vocab at you. All right, so first thing I want to do is set this equal to 0 in standard form. Subtract 1. I get 9x squared minus 1 equals 0. So what's missing is that middle term. Agreed? This is a trial and error because the 9's out front. And there's no GCF, so 2 sets of parentheses. I could use 3 and 3 or 9 and 1. I'm going to use that perfect square of 3 and 3. And then how do I multiply to get a negative 1? One positive and one negative. Yep. A plus one and a minus one. Now, you want to double check that you're right. Sometimes it looks like a perfect square or a difference of squares, and it's not. So there's my 9x squared. There's my negative 1. The outside's negative 3x. Positive 3x would cancel. I haven't solved it yet. You factored it. Some of us need to remember to take it one more step. What would make this 0? Well, some people want to say negative 1. If this is what I had, yes, negative 1 plus 1 is 0. But there's a 3 there. So what would make that 0? What is it? This one would be negative 1/3. Okay, if you don't see that in your head, set each piece. This is like saying A equals 0. So either this piece equals 0 or this piece equals 0. There's no shame in showing that to make sure you don't mess up your fraction or your negative sign. Subtract 1. I get 3x equals negative 1. Divide by 3. So I get x equals, there's that negative 1/3. This one you would add 1 and then divide by 3, and we get a positive 1/3. So those are my two different answers. Okay, let me leave myself some more room. All right, look at number 3 here. I need to set it equal to 0. I like to keep the x squared positive, so I'm going to leave this here and bring the 40 over, and I'm going to put it in standard form by putting that in the middle. So I have 0 equals 8x squared minus 40x plus 50. Okay, this would take me a little extra work if I didn't do a GCF. If I don't do a GCF, 8 has a couple factors, 50 has a couple factors. So if there's a GCF, do it. I was trying 8, but it doesn't work with 50. So what's your GCF? What? Just 2? Yep, 4 doesn't work either. So 2, and I'm left with 4x squared minus 20x plus 25. All right, now I need to factor it. Now, if you think about it, yep, I can use 2 and 2 or 4 and 1. I see that it starts and it ends with perfect squares, so I'm going to try the perfect square first. 2x and 2x. But if it doesn't work, I could go back and do 1 and 4. And what am I going to try to get for 25? What multiplies to 25? All right, 1 and 25 and 5 and 5, but guess what I'm trying first? 5 and 5. What kind of signs do we want? Say it again. It should be minus minus. Okay, I couldn't tell what you're saying. But I wanted to multiply to positive, so I need a plus plus or a minus minus. If I wanted to add up to negative, minus minus. Before you think it's done, you need to check it. 4x squared, 25. The outside's negative 10x, so yes, it is true. Okay? Take a second and tell me what x is. Oh, remember we talked about this the other day. If you were getting points for factoring, you would write this as the quantity 2x minus 5 squared. Because we're going to get the same answer twice. So how am I getting this answer? What's inside could equal 0. 2 will always be 2, but this could be 0. Add 5, and then divide by 2. So it's one answer of 5 halves. If you were graphing this, that would be where it hits off the vertex. Okay, I'll give you a minute. You try number 4 and number 5 on your own. All right, first thing you're going to do is you're going to set it equal to 0. So 4x squared minus 25. You're going to check if there's a GCF. There's not. It should show in your head like, hey, there's something different. It is a difference of squares. It's got to be a minus sign. So 2x plus 5 and 2x minus 5. And this is it. That's all the more I can do to write it. And then you're going to look at each piece. So if it helps you to write 2x plus 5 equals 0, each piece could be 0 on its own. And then you would solve it. Now, if you can do it in your head and you're not messing up the signs and you're not messing up the fractions, you might not need to show. That's supposed to be it's supposed to be a negative 5 on there. There we go, negative 5 halves. If you don't need to show this part, I'm fine, but you should show the factoring and then your final answers. and this one would end up being a positive 5 halves. We would add the 5 and then divide by 2. Okay, on this next one, I'm going to leave this 18x squared here so I don't have to deal with the negative, but you could deal with the negative. I'm going to subtract this over, so 18x squared minus 48x, and at the same time, I'm going to add 32 equals 0. Now, if you did it the other way, that's fine. You're going to factor out a negative sign. What was your GCF for this one that should help us? Just 2 again. 9x squared minus 24x, plus 16? Okay, so I'm going to jump into this trial and error factoring, but I see my perfect square, so I'm going to try the 3x first. I'm going to try the 4s, but there's other options, 9 and 1, 2 and 8, 16 and 1. All right, both negative, so I multiply to negative and add up. Negative 12x and negative 12x. I've got my middle term. Final answer for factoring would be written like that, but we are solving. Now, if there was an x out front, x could be 0, but there's no x out front. It's just in here, and x could be a positive 4/3. Are you okay with where I got that from? The 3x minus 4 could equal 0, add 4, and then divide by 3. Okay. So I would take 4/3. I would take 1 1/3. Okay. If you're solving them in Delta Math, it does not want decimals like 1.3 because that's rounded, so always keep a fraction. Okay, we're going to go backwards now. So this says using zeros to write a quadratic function. If you know the zeros of quadratic, you're going to work backwards. So I'm telling you the answers are 2 and negative 1. So please pay attention to this. It's actually not a bad concept. So if the zeros or the roots are 2 and negative 1, that would be your final answer. X equals 2, x equals negative 1. Well, where would I get that 2 from? If I had x minus 2, isn't 2 minus 2 0? So the 2 would come from this. Now, what would I have here that I would have had negative 1 as my answer? Like if I had a negative 1 here, negative 1, what would I do to it to get 0? I would add 1. So the x value, let me fix that. If I had x plus 1, I would have gotten the answer of negative 1. So do you see how I took my answer? I've got to think about the sign. If I had a negative 1, I would have added 1. If I had a 2, I would subtract 2. This would be my factoring. And if I want you to write a quadratic function, I'm asking you to write it in what? Standard form. So FOIL this. X squared, that's 1x. That's negative 2x. And last is negative 2. Add like terms. X squared minus x minus 2 equals 0. Now, that is the most basic answer. You could put something else on here, like multiply everything by 3 and have 3x squared minus 3x minus 6. Okay, you try the next one real quick. So if we have x equals 5 or x equals negative 5, well, if I had a 5 here, I'd have to subtract 5. So 5 minus 5 is 0. And if I had a negative 5 here, I'd have to add 5. So x plus 5 equals 0. So you're really just thinking about where would I have gotten that answer. When you go to FOIL this, you should end up with x squared minus 25 equals 0. Okay, well, where did I get that from? It's that positive and negative. You would have gotten x squared. The outside would have been positive 5x. The inside is negative 5x. And last would be a negative 25. And these cancel out, and this is called a difference of squares.